Hey folks, how's everybody doing today? Happy Thursday. Hope you're doing alright. We're going to finish up our little talk here on functions, and then we'll be pretty good. Go ahead and give that a pause. So finishing up functions this week, zyBooks Chapter 6, and then next week we're going to spend some time on strings and the midterm review. So I want to give you last year's midterm. I'll give it to you now so you can look at it, and then next week we'll go over and actually solve some of those problems, some of those examples.
Mommy needs help getting Jackson poo.
Alright, hang on. Alright, go out, please.
Want me to tell her you can't do it?
Just go out, please. Alright, so let me fire up PyCharm. So we left off working on some functions. Get that loading here. Should have opened PyCharm for. I keep meaning to do that, and I always forget. Hope you got your coffee ready. This is like one of my favorite mugs because it's huge. Like, this is the size of my fist. Next to it, it is just an amazing mug, and it's Snorlax, who is the best Pokemon. I should actually measure how many milliliters that cup holds. The decal's fitting. It's one of those days, right? Just one of those days. Oh, look at that. PyCharm just tanks my bitrate. Come on, PyCharm. We talked about function stubs. There we go. All right, yeah, so PyCharm, when that thing loads, it just kills my CPU, which affects my bitrate. So anyway, so we left off at 6.8. So we talked about function stubs and this idea of doing functional decomposition, taking a big problem and breaking it down into smaller and smaller and smaller and smaller bits. So you can solve one small problem at a time. Solve this small problem, solve this small problem. And we even looked at the next project and said, well, what if we used functions everywhere? Now, there's no requirement at all to use functions. You don't have to, because this was new stuff we've talked about before for that. But let's see. That one is due. Double check. Always go to Canvas here because I can never remember at the top of my head. Next week, 3:30 p.m. So we got one last week to work here on project 2, and then that'll put us next week. We'll have talked about strings. Come on, load back up here. So after the midterm, we'll come back with the next project here, and then we'll pick up our final project. So we'll do 2 weeks from classes up through files. We'll pick up our final project on the 16th, and then we'll have a month to work on that. I know we're off all week for Thanksgiving, so maybe only 3 weeks to work on it. But there's actually a little bit more of a gap, too, between when our finals are due and when our last day of class is, the way the calendar fit. They didn't have the final exam schedule posted, so I just picked like the last day of finals here for that. And what we're going to do for final projects is you'll be presenting them to me. So we should get a slot here where we can get together and meet that does not overlap the way they do their final exams. I haven't actually checked to see if that schedule came out yet, but it wasn't available at first. So we're going to get together, we're going to present our final projects. And it should be a lot of fun. We'll do a little Zoom meeting for that. So we can all hop on and do the screen share and present. So let me make a note of myself to check for that date. Project date. Okay, so we'll take a look and see when our slot is, and we'll do our presentation. So it might get moved up a little bit. We'll have to look and see here, but I think I picked the last possible date here for that. We go from there. So again, no exam, just that final project. And again, that one is worth a significant portion of your overall score here, like 25% of that last project. So we're going to finish up project 2, we'll have project 3, and that'll be the last individual project, and then the final project. Okay, hope things are going well. Labs, quizzes, make sure you're keeping up with the Zybook. Right? It's free points just for doing it here for the Zybook, right? Quizzes overall are going okay. I'd expected maybe a little bit better scores here or there, but it's whatever you put into it is what you're going to get out of it. So I think, definitely we're getting people getting 100% on every quiz, and then some people are not. And my guess is that the people who are not are just not putting in the time doing the reading, doing the practice, that sort of thing. But that's just a guess. I don't have any way to. I guess I could, right? I could go and see how much of the Zybook you've done. That would take a lot of time though, to look at that one-on-one. But I might be curious to see if you're keeping up with the Zybooks, if your quizzes scores are reflected in that. That might be a fun exercise too. Maybe we can do that later. So we'll keep up with the labs. Again, the midterm we're going to do during lab time. So we'll do no lab on strings. Here we're just going to take the midterm during that lab time. It'll be short and sweet. It's not meant to be a huge exam. The goal is that you can get it done in an hour here. And if you got the whole hour 45 in lab to work on it if you need to. So let me throw this on my other screen real quick, and I'll get last year's midterm for you in just a second. And make sure I don't click on the wrong buttons here. That was 2020. Wow, that was a year. 2020 was really a year. So because we only offer this course every fall. Okay, let's make sure this is good. Yes, all right, so we're good here. So we put it back on our screen. This was last year's. I'll print it off as a PDF for you. So it's 18 questions. There's 15 quiz-style questions, including a freebie here, just for acknowledging the academic integrity policy. Saying it's open book, open notes, open internet, but you may not work with other people, and you may not post questions on Chegg or other sites. I really thought that was obvious. Apparently it was not, or people just didn't care. All work is submitted to be the original, unless otherwise cited. So the midterm will go through, I think it goes through strings. I'll double check that here because we start that chapter, but we don't have a lab to practice it, but I think we'll be in good shape. Maybe we'll skip string. We'll see. I think we'll need strings, so it'll go through the strings chapter. But we won't have a separate quiz just for strings because we have the midterm instead, if that sounds all right. So again, just you put your name in the box saying you understand the policy, it's original work unless otherwise cited, and violations of the policy result in failure in the course being reported to the dean's office. It's bad. It's a lot of paperwork. I hate doing it. It makes me frustrated. So just don't, right? It's meant to be quick and easy for you. So in the rest, 14 more quiz-style questions. They're probably going to look very familiar to some of your quiz questions here. Just go on through. And then 3 long answer questions where I ask you to write a little snippet of code. So for 15 questions, if they take you 2 minutes per question, right? That's 30 minutes there, right? That's the goal. 2 minutes per question for those little quiz questions here. That puts you at 30 minutes. And then for each of these long answer questions, that leaves 10 minutes each to get these ones done. Okay, so this one here is write a function, difference of primes and non-primes through n number, given a number. So it returns the sum of all prime numbers 1 through n minus all non-prime numbers 1 through n. So, and I gave you an isPrime function. You don't even have to go out and Google it yourself. Here's an isPrime function I'll give you here. So we look at difference of primes and non-primes through n of 9. We'll return negative 11 because our primes are 2, 3, 5, 7. Non-primes are 1, 4, 6, 8, and 9. Right? I've heard 1 is not prime. If you're a math major and you know otherwise, please do let me know. But I've been told it's not prime because it doesn't have 2 divisors. And the rule is it has 2 divisors of 1 and itself. So if it is only 1, it doesn't have 2 divisors and is no longer prime, sure, I just went with it. So write a function. Again, a quick little function. It does a loop. It does some quick arithmetic. The goal was 10 minutes or less here for that. Write a function bad encryption given some string that returns a list of numbers where each number is the character's Unicode value plus its index position in the string. Right, so we can loop through a string. We've done loops. We've talked about getting things out index by index of a string. Right, so if we do this bad encryption, encryption's really not the right word for it here at all, but it's fine. We would get out a list of Unicode values plus the index. So we get the value for m plus 0. It's index 0. We get the value for I plus 1. So 106. We get the value for D 102, right, plus 2. Value for T plus 3. Value for E plus 4. Value for R plus 5. Value for M plus 6. Right, so M was originally 109. But now the next time you see it, because it's at index 6, it is 109 plus 6. So we get 115. Then we write a function reverse bad encryption given some list that returns a string where each letter is the character value number minus its index in the list. Right? So if we give it a list here, we get back out the original string. So just doing a quick little loop through each one of these, right? Adding something based on its index, turning it into a character. Getting those the ordinal values. Right, we looked at those ordinal values of characters. Right, so there's that one. And then another function, ensure none of the letters are in a string, given letters to check for and a string to check. That returns true if none of the letters in letters to check for are present in the string to check. So if we look at CIS and this is the midterm, good luck, would return false since there is a I in this is the midterm, good luck. There's also an S in this is the midterm, good luck. Right, so we get back a false result because one or more of the letters in the letters that we're checking are in the string that we're checking here. So 2 little functions. Okay, so some of the stuff we do in strings will be useful for this, but I think it's all doable with what we've already done with basic loops in strings, like looping through one character at a time. Right, so that's the goal for the midterm. So again, if these take you 10 minutes each, right, then that's 30 minutes, 2 minutes per quiz style question, puts you at 1 hour, but we've got the full hour 45 if we want it in the lab there. And that's the goal. So this one will, like, once you click start on it, it'll have a deadline of when you have to turn it in. Unlike the quizzes, the chapter quizzes, you can open up, come back to, save, come back to. This one you've got to submit within the hour 45. That make sense? All right, so let me print this out. I think I need to select everything. Is that how it worked? The usual print doesn't work, but I think if I grab it all and print, it works a little nicer here. Okay, and then if I print that to a PDF, I think we get a better result. Yeah, save as PDF. Let's take a peek. What does it look like here? So next week on the Thursday, we'll finish up any last little bit about strings that we had, and then I'll go over answers to all of these if you had any questions about them. But this way you get a little chance to practice. So you're going to get a different question, but it'll be a similar, hey, loop through a string and do something, right? Or write a function to do something, right? That sort of thing here. Okay, yeah, it looks like, so it's a little large here just because all those text boxes, but that's essentially it. So this should work here for our PDF. We'll save this as the practice midterm. CIS 151, practice midterm. Okay, and then we go back to our course, and I'll drop that in there for you. Practice midterm. Okay. Nope. Okay, that didn't. Oh, I gotta put it in files. That's why. This modules view confuses me sometimes. Apologies. Okay, and then I can go put it in the module. It's not really course information. I don't know. Can you just find it in files, or do you need a link to it? I can make an announcement, I guess, too, but you'll find it here in that file section of the course. You can just go there. I'll do an announcement too. Might as well. We've got not this Monday, but next Monday then. Right, it's going to be the midterm, so that puts us at 10:25. 10:25. On 10:25 during lab time. Let's do last year's midterm for review. Give that a little linky here. Nope, that's course links. There we go. Nope. My goodness, it doesn't show me files. Okay, sure, we'll just put files here then. Of course. It next Thursday. Class. Term exam. Be on 10:25. Regular lab time. So you don't need to come in person. Right? If you haven't been coming in person, that's okay. If you want to come in person, great, because then you can use those computers, no problem. If you just want to take it from home, that's fine. You're all agreeing not to work together, and I'll take your word for that, unless it proves otherwise that you've cheated. And then I'll have to do all sorts of paperwork and be upset with people. But I'm going to assume you're not. The goal is that you feel comfortable. It shouldn't be lots of stress. You should feel good walking into it, that you'll do well. That's the idea. Okay? So don't have to come in person. Have a 1 hour, 45-minute time limit once you hit start. And accordingly. So if something does happen and you lose power, text me right away if you're not in person, and let me know. Don't wait until the next day and say, oh, something wrong happened, something bad happened. I'm much less likely to work with you at that point. But if you tell me right away, I'll do what I can to work with you. And for those long answer questions, please use PyCharm. Right? Don't try and type into the box and assume you're typing good Python code and assume it works. Right? Write it out in Python, make sure it works. Actually run it and try it, and then you can copy paste into the text boxes there. Okay? I'll be able to figure out the code if you just copy paste it in. It's no big deal. The alignment will be a little bit funny, but it's okay. I can figure out tabs without much trouble at all. Okay? Any other questions, thoughts, or concerns about midterm coming up? And it is 20%. It's I get that's a decent chunk of your grade, and I apologize for large weighted exams, but thankfully that's the only one we have, and really just those 3 long answer questions is the goal there. Cool. Looks like I got a couple more labs to score for you here. Yeah, exclam class or course if you want more info there, Celis. Thanks for hanging out with us. Yeah, open book, open notes, open internet. You shouldn't need to Google things, right? And you're probably just going to end up down a rabbit hole if you start Googling things. because it's all getting sourced from the textbook and from the things I say in class. Yep. All right. Let's take a look at where we left off here, 6.8. Yeah, XAM course for more information there, Celis, in chat. Yeah, there you go. All right, so where we left off with our functions here is Python is actually kind of interesting in that the way that it works and the way that it loads things, right, as it reads the file, right, because it's in interpreted language, it's reading the file top down and then executing it here. These actually get loaded, and you can pass functions as objects, because functions are objects. So just like I can pass a length and a width, and I can pass things, you can pass a function to something else, which is super weird, but you can. Not too big of a deal here. Again, a little weird, but sure, you can. So if we were to define a function here, like let's call this print shape, and then print shape is going to print. Let's just do, I don't know, like, let's do a little star here, or a little square. Nothing interesting. We'll print a little square. Okay, so I can have a print shape function. Then I can make another function called, I don't know, let's call this print base here. Yeah, let's do this. Make this a little prettier. Let's do the 5. Okay, we'll do a nice little like equilateral triangle here, right? So if we were to print a base, then given a top, we'll call this the top here. We're going to make a little tree, print top. Given the top here, so top as an argument, then if it's a function, I can say top parentheses to call the function top. So we can do, this is, let's do star top. And then we'll make another one of these. We'll have a define print, how about we do dash top. That does the same thing, but we're going to print with dashes instead of stars. One, two, three, four, 5. All right. So whatever top function you give it, it's going to call that function and do that thing. Then we're going to print the base here. So that's probably what, that one, and pipe, pipe, pipe. And then we'll print, I'll do that one more time. Print a little base for it here. Yeah, do some pine trees. Yeah, it's the top of a pine tree. Okay, so then in my code, if I wanted to, then I could call print base given a top function. So when you're passing a function here, I would say this is my print dash top without the parentheses. So you can pass a function by name without parentheses. This is the name of the function. So it says, hey, do this function. Right, here's the function. Then when I add the parentheses up here, it will call that function. Right, whatever one we gave it, because we add the parentheses now, it says, oh, do the function thing. Okay, so let's give that a run. And now we get the dash top. Right, or we could change it here if we wanted to give it a different dash top. We could give it the star top. Right, we could pass it the print star top function. This is really weird. Passing functions as arguments is a little funny here, but you can. Just know that that's legal. So that also means then when we're playing with our functions or doing function things, we can do other silly things like print star top without the parentheses is not going to do anything. Right? It just says, oh, sure, here's the name of a function. Or if you have a function that returns something, do we have any? Yeah, like this convert Fahrenheit to Celsius. That was probably better. If I said, hey, my temp is equal to convert Fahrenheit to Celsius, and I forget to use the parentheses, temp is now pointed at this function. It says, oh, okay, now temp is a function, so I can say temp given 10. And we'll convert Fahrenheit to Celsius given the 10 degrees Fahrenheit here. Right, because we said, hey, temp is essentially now we're saying temp is now a function. We're assigning the name temp to this function because we didn't use the parentheses. Function to a variable. So then you get to call that function using the variable name, parentheses, any arguments here. This gets super crazy. It's a really weird thing that happens, but just it's allowable. And something, you know, there are some cases where it's nice to be able to hand a function to a method or to another function and say, hey, do this thing, right, with whatever this one is. Okay. So I'll take those ones out. All right, other common errors that we run into with functions, right, are we screw things up just by arithmetic, or we screw things up by variable names. It's really easy to get mixed up with some of these things and either do them in the wrong order, or if we're copy pasting things, to forget to rename things, right? If we wanted to convert this formula, we wanted to make another one and say, hey, let's do Celsius to Fahrenheit. Celsius to Fahrenheit. Fahrenheit. Here, given Celsius, right? Okay, well now I need to start renaming some variables. And if I don't rename them the right way, or if I forget to rename like the return here, we're going to run into trouble. So let's change that. So it would be Celsius plus 32, right? Oh no, not plus 32. We do that after. It'd be Celsius times equals 9 divided by 5, you take 9/5 of it, and then you add 32, right? And then we could return the value. So I think this will work. I think we're avoiding any of our errors here. But if I did forget to rename something, right, if we're always saying, hey, maybe this would be our new Fahrenheit value, Fahrenheit equals then Celsius times 5/9, and then Fahrenheit plus 32, Celsius, there we go. And if I forget to rename my return Celsius, well, now I've screwed up my formula. Right? I need to make sure I'm renaming all the things here. So just be careful if you're doing copy pasting. Be careful of your order of operations, those sorts of things here. All right, so there's a technical term when it comes to variables here. We've talked about it a little bit, this idea of scope. Did I misspell it again? Celsius? Celsius. Okay, there we go. Thank you. You get like 10 bonus points there, Mr. Hamill. The downside is they're not actually worth anything. So I give them away like candy because they don't mean anything. So remember when we looked at if you pass Fahrenheit as an argument here, we've passed it by a copy, so if I go and change Fahrenheit, it's not going to change my original Fahrenheit value. Because the scope of this variable is it's local. It only exists within this variable here. That's the scope of it. So it's a local variable. It's local to that function. Now there are ways that you can get at a variable outside of the function. It's generally considered bad form. Exactly like whose line is it anyway? Everything's made up, the points don't matter. Yep, that is exactly what's happening here. We're just doing it with Python, so it's not quite as funny. All right. So if I wanted to get at the other Fahrenheit value and actually change it, I could say, hey, I want global Fahrenheit. Get the global Fahrenheit value. Fahrenheit? Oh, it doesn't like that's not the same one here. So what do we call it over here? We called it temp and F. There we go. We'll call it temp and F. So I say global temp and F, and it says, oh, go get the variable that was defined at the global scope. And for us, what global scope means is it was defined outside of a function. So a variable over here has a global scope. It was defined outside of a function. It's not local to a function. So you have local and you have global. So there's these different scopes of our variables here. Now changing temp and F is going to change it here. Because I said, hey, give me the global temp and F and do something with it. Where did it go here? Temp and F. Right? We can still do the same calculation, but our temp here will change. So that's no longer the line. We don't want that anymore. Let's give this a run. Yep, stop and run. Terminate. Here we go. Uh-oh. Name temp and F is not defined. Well, we tried to get a global value here, but at the point in which this line of code was read, this variable had not been declared as temp and F because we were reading it from the top down, right? We didn't declare a temp and F variable till down here. So to use a global variable, you need to essentially define them up at the top. We'll say temp in F equals, I don't know, just 0 for now or something, right? We can give it a value later, but if you define it above before the function is read, then when we go to read the function, it says, okay, go find this global variable. There's one that exists within that scope. Enter temperature in F. Let's do 32. We get, okay, oh, we never printed it out again here. Where's our temp in F? We should print that again. Yeah, we converted, and then we'll print our temp in F again. Print temp in F. The new value 4. Oops. Is, I'll make that a little formatted string here. Love these formatted strings. It's fantastic. Okay, we give that a run. Stop and run. Yep. 32. Oh, sure, 32. Now it became 82, right? Because we were able to modify it using that global variable. And again, it's actually considered generally bad form. So we try not to use global variables or like inside of functions, go and access them. So this is bad form. Don't do it. We'll just try and stay away from it. There's no need, right? If you need a value, pass it. And if you need to give back a value, return it. That's the correct way to do things with functions, right? We shouldn't be messing with global variables. And then there's also one other scope. So when we go to use variables, we first check the local scope. Does it exist within my function? Then we check global. Does it exist within my program? Then we check the built-in scope. That's all the stuff in the Python library, like int and string and list and range and all those functions we've been using that are built into Python. That's the built-in scope. And it warns us, like if you do something like, where's our like function here? We said sum equals 10. It says, as a little warning here, Shadow's built-in name sum. Local variable sum never used. That's just a warning because we never did anything with it. But it's telling us, hey, there was a thing called sum, and now you're changing what sum does. So if I make a list here and I have like some list equals a list of 10, 20, and 30, and I try and take the sum of some list, it's going to be a little confused here. You know, total equals sum of some list, and print the total. Let's see what it does here. So that's when we print how are you, right? So that should happen. Print hello. Print hello says print how are you. Okay, so we'll get there eventually. Stop and run. 32. Uh-oh. Int object is not callable. Right? We can't say sum parentheses do something. It's not a function. Functions are callable. We said sum is 10. So when we try and put some parentheses around it, it says, oh, sum's not a function. That doesn't work. Right? So we got to be careful here. So this is using from the built-in scope is generally bad form. Again, just another thing to avoid. So now it would work otherwise without it here. But if we assign something to that word, right, we're hiding it because the local scope is checked first, then the global scope, and then the built-in scope. All right, so we looked at some function arguments here. You can give it Celsius, you can give it Fahrenheit, you can give it length, you can give it width, you can even give default values, which is pretty cool. Let's see. Yep, so some things to be aware of, right? If we were to make a function like, I don't know, find largest value in list given some list. Yeah, definitely. Calling it the result or something relevant to what we're doing is much better. I try and use the word total if I meant a sum, because I do like the word sum, but it's also a total. And then you don't hide that function sum. So if we want to find the largest value in a list, if we give it some list, we can do that, right? So we can say the largest is, we're going to say some list of 0. We're going to assume the first thing is the largest unless we know otherwise, right? Then what I need to do, I'm going to loop through. So for item in some list, if the item is greater than the largest, then the largest equals the item. We're done, we'll return the largest, right? Start with the first thing, index of 0, first thing in the list, and then see if it's bigger, you now have a new biggest, new largest, and just keep on going for every item. Okay, we can get the largest out. So we can say, hey, let's make a list, I don't know, numbers. So why don't you shout some numbers out at me, and I'll throw them in here, and then we'll try that function. We'll say print the find largest value given my numbers list here. So what number should I put in here? Just throw anything in the chat while I drink my coffee. No one has any numbers? It's like the easiest participation. You just type a number in the chat. I can come up with my own numbers, I guess. That's okay. I do know how to count. 17. Thank you, Trouble Man. You get like 17 bonus points for participating. You have 64 more bonus points for participating. 8 more bonus points for participating. Thank you very much. You know how to type numbers. I know, it's Thursday. We're hoping it's Friday. You know, that's okay. We're getting there. So, and I'll throw in 42. We'll call that good enough. So we'll make a list of numbers, and then we'll pass it to our function. Our function returns a value, so we can just print it right back out. We'll give that a run, and we see 64 is the largest number in that, in that list. Right? That was correct. Perfect. So some things about when we pass some list. Some list is, the variable itself is a location in memory. So let me pull up my Word here, because I think it works better than whiteboard. Although I do like the whiteboard, but I think it makes everything laggy, I've noticed. Let's try this. So when I make a list, Python tells the operating system, hey, I need some memory location. I want a list. The operating system says, sure, here you go, here's x32fb. Here's a location in memory, right? We use X for hexadecimal notation, I don't know why. And at that location in memory then, I can store some things. A little bit of extra magic stuff happens, don't worry too much about it behind the scenes, because they can get bigger, they can get smaller, whatever. But we threw a bunch of numbers in there. We threw 17, we threw 64, we threw 8, and 42 in here. When I called that function, right, find largest value, when we gave it the list, we said, hey, here's the list, here's the memory address of my list. Go for it. Go nuts. I didn't make a copy of the list. Right? When we pass integer values, we're passing copies. Because we're passing the value of it. So the value of a list variable is the memory address. The value of an integer is the integer value. Right? So things that are referencing objects are containers and things, they're reference types. That means I have a memory reference of where it is. So when I pass that, it has access to the list, and it can do all sorts of cool things. What it can't do is say, hey, x32fb, you now equal x, I don't know, 39fa. It can't change that here. Because when we come back, right, our original list is still looking at this location. So if we were to say, okay, inside of here, instead, if we wanted some list to equal a new list, 1, 2, 3, 4, 5, right? We're not going to change the value of our list inside of it. I don't know what the stars were there, sorry. 0 tells the parser it's dealing with a constant and not an identifier reserved word, so they still need to specify the number base. X is an arbitrary choice. Oh, is that why we use X for hex? I don't actually know why we've always used X for hex. That's just something people do, I guess. So if I were to try and change some list here, right, and then I print my numbers, I've handed a memory address here, and then I say, oh, you don't point at that memory address anymore, you point at this new location in memory. Our original list here is not going to change. Our some numbers list is not going to change, right? We haven't changed it. We changed it inside the function, but we didn't affect the original here. But what you can do, right, is I can take my sum list and I can append a value. Let's append 100,000. Or no, that's a million, right? We'll add in our separators. We'll append 1,000,000 here. And now when we run it, I now have that value there because remember, lists are mutable. You can change lists. So I'm not reassigning it. I'm not pointing it at a brand new list, but I am modifying the list in its existing space. So anything that you pass that is mutable can be changed. Right? We can't reassign it completely, but you can change it. You can't reassign, you can modify. Right? Mutable objects. So with a string, because strings are immutable, right, we can't change the original string. With a list, though, lists are mutable. I can change the values inside of it if I want to. Or I could say, you know, I could set them all to 0 if I so cared to. Right? Not with this notation. Remember, this is a read-only notation. But if we want to do, like, essentially 0 out, so let's have a 0 out list given some list, I could loop through by index. I'm going to say for index in range, length of the sum list. I'm going to take sum list at the index and assign it 0. Right? I can modify mutable objects. I can modify the list because it's mutable. Here, I'm just going to put a 0 in for every one of them here. So if we 0 out the list, given my numbers, and I print numbers again, we're going to see it changed it to all zeros. Stop and run. We got all zeros out, right? Because we are able to modify those values. You have to be a little bit careful when you're dealing with objects that are mutable, when you pass them to functions. That's the whole big story here. You just got to be careful. Other fun ways that you can call functions, right? We had our a length and width. So far when we did length and width here, we passed the first thing and then we passed the second thing, and it said, okay, the first thing was length, the second thing is width. If you wanted to, you could call it a different way. We could say, hey, we'll get, oh, sure, we could do the same area perimeter unpacking here. Why not? And generally, it's useful if you have more than like 2 parameters. If you have a lot of parameters, I could say, hey, width equals. And then what am I going to pass? I'm going to pass the width variable, comma, length equals. I'm going to pass my length variable. Oops, length here. So this is using keyword arguments, saying, hey, the argument named width, pass this value. And then you can do them out of order. Because before, these are considered positional. The first position, the second position are what we're passing. Right? So if you're not being careful, it was possible we could screw it up if I passed width and then length. Now, for our purposes, we're going to get the same results out, but for other functions, right, the order might matter. And it could be important. So you can use keyword arguments to specify, okay, this is exactly what it is. So you can use keyword arguments, you can use positional, you can mix and match, but positionals have to come first, which is funny, but that's how it works. You can look at some of those. We've looked at default values. So if you wanted to have a function that has a default, right? We've done, hey, this was a default character, which is fine. You don't want to use defaults that are mutable. Weird things happen, like a list here. So if I were to have a function here, let's call it, I don't know, add to list, given a value, and I'll say, okay, if you don't give me a list here, I'll assume it's a brand new list. And I'll take my list and I'm going to append the value, and I'll return the list here. Because I might have made a brand new one here, right? So I'm going to give you a list, and I'm going to return that list. We can take numbers, and then I could say, like, add to list, let's add a 10. So instead of giving it fixed numbers, let's just say, hey, add to list 10. And then we can say numbers plus equals, I'm sorry, we can reassign it again because we're returning the list, or we can just let it get modified. Either way is okay. We can say add to list of 20, and then we'll give it the numbers list. Right? Or we can just ignore that it's returning anything because we know it's modifying it. Right? Either way is okay here. So we'll add the 20 here, and then we'll print our numbers list. So we should have 10 and 20. Right? Because we added a 10 to an empty list, and then we added a 20 to the existing list. And then what we could say, let's take our numbers, how about it equals add to list. Let me start a brand new one here, right? Let's start a list with just 42. We'll call this other numbers. How about that? And let's print our other numbers list. When I run this one now, I should just get the 42, right? Because we added the list, a numbers here. Oh, actually, I gotta kill that and then start. Uh-oh, I got the 10 and the 20. I should have only gotten the 42. But what happens is when you give it a default value here that's mutable like this, it makes it once when it loads the function into memory, and then it's always assigned the exact same list here. So this is not good form for a default here for a list or a mutable object, because it's going to load it one time into memory, right? And then we're going to keep working with that exact same one. So we're not getting a brand new one every time we don't give it a list. We're getting the same original one. Gotta be careful with that one. So the better way of doing that is say, let's default it to none. That's our special keyword for doesn't exist. And I can say, hey, if list is none, then list equals a new list. Otherwise, you can just append. Right? Oh, yeah, okay. Using our word list here is bad, but that's okay. We won't worry too much about that. Okay, we all right so far? So it's getting funky with some really cool things you can do with functions here. And now we're going to add even more to it here. So I like this idea here. This one's kind of fun. You can have a unknown, unspecified number of arguments. So I'm a big fan of this sandwich example, but I'm going to do hamburger. So let's do a create hamburger, burger, given the bread or the bun, right? What bun you want? Do you like the sesame seed bun, or do you like a onion bun, or do you like just a plain white bread bun? You know, you gotta pick what kind of bun you want. And then let's go with the meat that you want, right? Whether or not you're doing 2 patties or a single patty or a quarter-pound patty, or you're going with maybe like a turkey burger or a veggie burger. Then the toppings that we want, I'm gonna say toppings with star toppings. What that means is they can give me any number of toppings that they want. Right, so then what I can do then, I'm just going to print, I'm going to say print the bun, or no, I want the meat first. I will do a little formatted string here. Right, it's the meat on a bun here, right? And then what we can do, we can check, hey, if the length of toppings is greater than 0. Right? If I have some toppings, then I'm going to print. I want everything here. So then I'll say for item in toppings. So there's no star when we reference it here. There's only a star here, meaning it's a arbitrary argument list. Any number of toppings here. We'll print the item. Oh, I'm sorry, I missed the mute there. Whew, apologies about that. We'll print out the item here. So what I could do then, if I wanted to make a hamburger, create hamburger, I can say, hey, I want my onion bun, and I want a quarter pound here, and then I want it with pickles, and I want it with onions, and I want it with lettuce here. Thank you, Trumpet Man. So this star toppings means I can give it any number of arguments here that I want. I don't need to define it as a list here that would have to be empty or default. I can give it any number of toppings. And if you want a plain burger, like my daughter likes, she likes just a white bread, white bun, just the quarter-pound burger here. She doesn't like anything on it, just completely plain, which is like the most boring thing in the world, and it hurts me every time we go through the drive-thru, but that's okay. Toppings won't have any values, and that's fine. So I get my quarter pound on an onion bun with pickles, onions, and lettuce. She gets her quarter pound on a white bun. Quarter pounder? Is it ER? I don't know. Quarter pounder. Maybe we should add some cheese too, but you can give it an arbitrary list of toppings. You can also do a similar thing where you get a essentially a dictionary or keyword arguments using 2 stars, and that just gets even funnier. We're not going to bother with it. Don't worry too much about it here, but you can do some fun things. Hydration. Thank you so much, Mr. Hamill. I appreciate the reminder. And a posture check. Yeah, I'm slouching. Could you tell? And a stretch. Man, you're just using up all those channel points. So I actually have this really cool backboard, which is like helpful for stretching, but if I stick it behind me, I also make sure I keep pretty decent posture, because it doesn't let me slouch very well. There we go. That feels better. And then a stretch. Oh, man, we're getting there. All right, we talked about multiple function outputs. Technically, you can only return a single thing from a function, but if you return more than one, it actually just packs them into a tuple for you. And you can do that packing and the unpacking. Yeah, do that in real life word ban. It's fun to teach about functions if you ban the word function. It's just fun. All right, and then document strings, they're fantastic. Go read about it. I'm not going to bother spending any time here. Other instructors and profs are really big on documentation, and that's okay. There's nothing wrong with it here, but I would rather spend the time teaching you how to code and figure if you learn how to code, you can learn how to do the documentation. Right? I'm not going to waste our class time on teaching you how to document things and then go code them. Right? I just want you to code them, and if you can figure that out, I'm sure you can figure out the documentation here. Okay, so no big deal there. But do that section in the SciBook there. Yeah, and that gets us through functions. Fantastic. That puts us through. All right, any other questions, thoughts, concerns about functions? We'll come Monday lab time. We'll do our lab on functions. We'll get a couple different functions that you need to write. Some practice doing these things that accept different values and return different values and do all sorts of that kind of fun stuff here. And again, if you'd like to use functions for project 2, go for it. Use the shell I started, or make your own. Right? There's no wrong way of going about it here. That's part of the fun of computer science, and it really is being an art and a science. The art of it is how do we design our solutions in a certain way. And there's all sorts of ways to go about solving problems. Right? Just because I break it down one way doesn't mean that's the only way to break things down. There's lots of different ways we could go about it, lots of different approaches, which is fun. Okay? So you folks are doing fantastic. We are halfway through now, which is crazy to think. Mid-October, we're halfway through. We have a couple chapters remaining. Okay, we're going to talk about strings from Chapter 7. We'll talk about lists and dictionaries from Chapter 8, classes in Chapter 9, exceptions and modules, files, and then we just briefly touch on inheritance, recursion, because, again, those are topics we're going to pick up if you continue on next semester in 2001. And we'll spend a little bit of time on plotting and basic graphics as well. Plotting is fantastic. There's a really great library that you can use in Python to make all sorts of amazing graphs. We're going to do some really boring ones because you got to start somewhere. But just we'll look at all the really pretty ones and cool things you can do with them. It's lots of fun. And then the basic graphics, making it like a user interface that you can click on instead of everything being, you have to type stuff into the console. We'll spend a little bit of time talking about it. And then we'll do our final project presentations. So I would like you folks to work in pairs for the final project. I understand we're kind of still in the middle of a global pandemic, so if you're not comfortable with that, perfectly fine. If you just want to do individuals, work with that. That's okay. But I think pairing up is going to give you a better product. And we can even do it virtually, right? We have all sorts of virtual tools for working together where you can bounce your ideas off of each other, work things. If you've put some time into designing, even if you want to do some drawings, right? We looked at those activity diagrams where like, hey, here's the flow of my program. Here's these diamond decision points. Things will go here and there. We're going to look at some other UML diagrams when we get to classes that you can write as well once we get to the second half here. But that puts us first half of the course done, and then second half of the course coming up, and the final project. And we'll be done with the fall semester, believe it or not. So let me go look that up on UN Dearborn. Final schedule? That's not what it's called. Yeah, final exam schedule. Missed the exam word. Let's see if they actually published that yet for us. Oh, they did. All right. So technically we're an in-person class, not an online class because we meet for labs, I believe. Let's double check that. We'll find out which list we're in. We're supposed to not use Dropbox. That's lovely. This is supposed to stop working at the end of October. That's fun, right? So let's find 1501. See what we get here. Come on, search, don't let me down. There we go. 1501. Monday, December 13th. Oh, that's ugly. That's earlier than I wanted it to be. 3 to 6 p.m. Oof. You don't. Oh, the dad joke redemptions are fantastic. I got some really good ones here. Like, I was out washing the car with my son the other day, and he asked if we could use a sponge instead. All right, so Monday, December 13th. That's not great, because that puts us a little earlier than I want it to be. That's like right after we finish here. I'd rather have a little more time, but I guess it's just a couple days early. That should be okay. We'll talk about the final project here, the 16th. So we still get almost a whole month to work on it, which I think should be good. So let me get this updated here. So we're going to get together and present them. It's a good chance to just talk about your code, have some fun there. Let's see, school. Fall. Here we go. Let's go update that. So 12:13, right? 3 to 6 p.m. Final project presentations via Zoom here. So I'll put out a Zoom link when we're done. Okay. Files, drop this guy in. No, okay, that didn't work. Dropped it in the wrong spot, I guess. Hit that box. There we go. And replace. Unable to trim. Oh, I have to close it first. Come on. Work with me here. Canvas. Cooperate. Place. There we go. Okay. So I got the latest and greatest version here. You know, Mr. Hamill, I was also thinking the human race has come really far. Back to 1903, we had our first flight, or powered flight, right? The Wright brothers at Kitty Hawk. So in the last 100 and not even 20 years, right, we've gone from not being able to fly at all to we're planning trips to Mars, which is really pretty cool. So we've come a long way. But I think of all of the inventions, you know, in the last 120 years, I really do think the whiteboard is the most remarkable. Okay, there we go. So we got our right time in here based on our schedule, 3 to 6. So we don't need to meet in person. We can just do it over Zoom. I think will be easier. We can all take turns screen sharing, but you should have this time free for you here. Okay, and we'll go with that. All right, any other thoughts, questions, or concerns? Feeling all right? We got to practice some functions in lab. We'll keep on trucking. All right, folks, let's go see if there's anyone we can go pester online for fun. Go to my ending screen here as it loads a little better, and see who's around. Let's see who's around. Some of our streaming friends. You just got it. We'll go bother again. Bother. He's always fun. So go learn some things. He does all sorts of fun electronics. Remarkable. You can remark the board. All right. Take care, everybody. I'll see you around.